All right, folks, we're going to get started in about 5 minutes. If you can hear me, just type yes into the Google Doc. Should be seeing the presentation slide. Says Chapter 6 Overview. Hope you can see that just fine. Just let me know if you can hear me. So I know that you're there. If you need to get to the Google Doc, you can check out the email where I sent it. The Google Doc is where you can ask questions, comments, follow-up questions, and good stuff like that. So we just got about another 4 minutes or so, and we're going to get started. Just let me know if you can hear me. Okay, Sadie and Gwen, I see you're in the Google Doc. That's great. If you can hear me, just type yes in the appropriate section right above the questions. Have some space there. So let me know if you can hear me. I got a new microphone, so I just want to make sure it's working. Wait another few minutes, see if anybody else joins us. And then we'll run through the presentation for about 10 minutes, and then I'll take your questions. All right, just another couple minutes. Let me know if you can hear me, if the sound is working right. We'll get started in about 2 minutes. Let me know if you can hear me loud and clear. Just testing out the new microphone. Thank you. Let's change that color. All right. And for those of the people that don't join us, well, they'll be able to watch the replay for any help there. But those of you who are with us, you'll get the special treatment. You'll get to ask your live questions. I can pull up problems, and we can get started with that. So we'll just wait about another minute, and then we'll get started, another minute or two, and we will get started. I'm just going to make sure. I have the ability now to copy and paste any question into a thing called Sketchpad. So if you have like a specific question from a TPS or something, I can paste it into the Sketchpad thing real quick, and then I can draw on it. So I think that'll help us with going over specific questions that you might have from TPS or other problems. So if you do have specific questions and you're getting them ready, if you can, if it's a question from a TPS, specify where it's from, or let me know that, and I'll be able to help you there. But I'm just testing it out now, and Sketchpad works pretty easily. All right, so just about another 30 seconds, we'll get started with the presentation. Chapter 6 overview for the quiz tomorrow, and hopefully everybody is ready to go. And if not, you're going to study tonight to get ready. Let's see. I'm just going to get the Google Doc out. All right, Sadie and Gwen, you're the only two I see in the Google Doc. Perhaps others are joining us and don't have the doc open, or maybe they're just going to watch the replay. But feel free to type questions as we go along. Anyone who joins us can type questions as well. I see Brenda just joined us as well. Hopefully, Brenda, you can hear me. Just type yes if you can in the Google Doc, and we're going to get started. Okay, so to our presentation, you should see on your screen Chapter 6 Overview by Mr. DeRosa. And here we go. So what do you need to know for this quiz tomorrow? First off, just a note on the quiz format, and this is mostly on your review sheet, but there's no calculators allowed, so take note of that. You have to use your good old mental math and arithmetic. You can do a side problem if you need to, if the numbers are such that you don't like them, but no calculators. It'll be 5 questions, about the 40 minutes you'll have, so you'll have pretty much the whole period. And here's how the questions are going to be broken down. There'll be one question on matching graphs to descriptions. The best way to practice for that is to look at the back of the review sheet, see if you can match up those equations in those graphs. By description, it could be an equation. It could be a statement like the range is all real numbers, or it could be a statement like the y-intercept is positive and the x-intercept is negative, or it could be something like it contains a cube root. Any of those things would count as descriptions, and then you should be able to identify of the choices which graph that matches up with. All right, so the best way to practice for that is look at the back of the review sheet. There'll also be a bunch of problems on simplifying radicals. One question in particular, I know we had a long discussion with this in class, and I can discuss it again in the Q&A, but is absolute value needed? I'll mention that later in the presentation. Do you know your properties? And that means laws of exponents as well as radical properties that we learned in 6.1 and 6.2. Can you apply those? Can you change a rational exponent, a fraction exponent, into radical form? Can you break down radicals with perfect cubes and perfect fourths? Can you deal with negative fraction exponents? All those kinds of things from the TPSs. It's really testing, have you practiced? Have you practiced doing those problems? Do you really understand it? And can you do it again under some pressure of the quiz? And then lastly, graphing and solving. There'll be a problem where you have to graph a cube root or a square root function of some sort. Won't have absolute value in it. Maybe an extra credit question, but the regular one will not have absolute value. It'll just be a graphing question, state the domain and range, and the solving question will be a radical equation, and you'll have to deal with that as well as extraneous solutions. A couple more specifics. Matching tips. So how are you going to match those first 5 questions well? Well, one, you should know the parent functions. If you know the parent functions, you'll be able to immediately look at something and say, oh, that looks like a cube root, or that looks like a square root function, or that looks like a cube function, y equals x cubed, something like that, or that looks like a parabola, therefore it's y equals x squared. Those parent functions are going to be used throughout the year, and you just got to know. Secondly, find the center. I should have put center in quotes there, h comma k, of whatever you're dealing with, because they don't all have centers. We call the vertex of a parabola. We call like that middle point of the cube root function. But find that starting point, and then you're going to go from there and see what you can construct in the graph, whether it's x or y intercepts, and you should know the shape based on the parent function. Understand the effects of a being negative or a being positive. A is that number in front of the parent function. It's multiplied. When you transform a function, we say it's like a times square root of x, or a times cube root of x. So here are just 2 examples. Whether this is a -2 here or a 2 is going to affect the shape of the graph. If it's negative, it's going to go down in this fashion. And if it's positive, it's going to go up in this fashion. And you should know how the cube root is affected by negatives as well. So check the back of the review sheet, find all those domain and ranges, and know how to analyze domain and range based on a graph equation. Okay, so all of those skills, domain, range, effects of the function, center of the function, will allow you to match things up. So that's some good things to practice there. Simplifying tips. And I hope all of you can hear me. If you can't, then you got to check your audio. I see 3 yeses here of people who can hear me, but I hope you can. If there's an issue, just type a comment under there, and I'll try to deal with that. But I have a new microphone on, so I'm hoping it sounds pretty clear. And if not, we can always go back to the old one. But anyway, on to some simplifying tips. Again, I said it before, you got to know all your laws of exponents, all properties of radicals. Those properties are spelled out in 6.1 and 6.2 notes. Laws of exponents are from a prior chapter, but practice the TPS problems and homework again. If you practice, then you'll know if you understand it or if you don't. And if anything looks scary, oops, sorry about that. If anything looks scary, ask me about it now and learn how to do it because it could be on the quiz. You might not have time to ask on the webinar. You can email me. You might want to ask a friend to explain it. But any of those TPS questions or homework problems are fair game for the quiz. There was 1 or 2 homework problems where the numbers were extremely high. The answer had like a radicand of 62,894 or something. That would not be on there. But anything else would be fair game unless the numbers are really, really high. So the simplifying question is 1 question, 6 parts, and they're all 2-point simplifying problems. So it's basically you get it or you don't, and it's going to take practice to get ready. Simplifying tips number 2. Know when absolute value is needed. So we talked about this on TPS 6.6. Examine properties 3 through 5 in the notes carefully. When we did those like 5 properties, properties 3 through 5 are going to tell you by rule if absolute value is needed. So if you're a person who you don't really want to think that much on your feet, you'd rather just have it down as a rule, well then you really got to know properties 3 through 5. But are absolute value bars needed in the following examples? I'm going to quickly talk you through the yeses and nos and explain why. But again, if you'd rather just have a hard and fast rule, you'd have to look at properties 3 through 5. So first, this one, the cube root of x cubed. No, absolute value is not needed to simplify that. It would simply be x. Because when you're taking a cube root, that cube root will account for whether the result is going to be negative or positive. Or in other words, if you have the cube root of a negative, the answer will be negative. And if you have the cube root of a positive, the answer will be positive. So the sign doesn't change, right? The sign will still stay the same. When you take that cube root, you get down to whatever that x is. You find out what that x is. You know it exactly. You're not finding the absolute value of x. Okay, the cube root of 8 is simply -2. The cube root of -8 is -2. The cube root of 8 is +2. It just matches the x exactly. Doing that. In the next example, the 4th root of x to the 4th, where x to the 4th is in the radicand. Let me start this out with a question. Oh, first of all, if you're looking at property 3, this is properties 4 and 5. If you're looking at properties 4 and 5, you know that this answer is yes by rule, that you need absolute value bars. The answer will be absolute value of x. But let's say you weren't memorizing these properties. How do you know this? Well, let me ask you a question. That x in there, it's raised to the 4th power. Order of operations says we'd have to do x to the 4th first, and then take the 4th root. If we have to do x to the 4th first, do you know if x is negative or positive by looking at this expression? Granted, we're going to be allowed to assume that all of these expressions represent a real number. So imaginary numbers are disallowed. However, can you tell by looking at that whether x to the 4th, the 4th root of x to the 4th, can you tell that x is negative or x is positive? And upon reflection, you might come to the answer that the answer is no, you can't tell. And the reason is because whether you raise a negative number here to the 4th power or a positive number to the 4th power, whatever that x is, whether negative or positive, when you raise it to the 4th, it will become positive. But then, when you take the 4th root of a positive, right? When you take the 4th root of a positive, you get a positive, all right? Because the 4th root of something means what times itself 4 times gives you the radicand, and if you're multiplying an even number of times, it will have to come out positive, whether it's a negative an even number of times or a positive an even number of times, it'll have to come out positive. So since this result will always be positive, whether x is negative or positive, we must include absolute value bars to denote that positive. Because in reality, x could be negative. So we can't just say this equals x, because what if x is negative? Well, you can't get a negative by taking the fourth root of x to the fourth. So since you can't get a negative, you can only get a positive. To be safe, we must say that this equals the absolute value of x. Whether x is positive or negative, the absolute value of x will be positive, and so that's what this equals. So the answer is yes, you need absolute value bars. And feel free to ask me more about that on the questions, and I can go to the sketch pad and try to draw it up even further. This one you don't need absolute value bars because you can simplify this to x to the fourth. I'm sorry, x to the 4 over 2. You can take that square root and rewrite it as a fractional exponent here. So it's x to the 4 over 2, which is x squared. Since x squared is always positive, it's redundant to put the absolute value bars. I said it was lame in class. You just don't need it. Similarly for this one, since that x under there, we're told that this expression is a real number. This x under here already has to be positive, because if this x were not positive, then the sixth root would produce an imaginary number. It wouldn't produce a real number, because you can't have the sixth root of a negative, or you can't have a real number equal to the sixth root of a negative. So since this is the sixth root and we just have an x, and then we know automatically off the bat that this x must be positive, or 0. It could be greater than or equal to 0. So therefore, since we know the x is greater than or equal to 0, when we raise it to the sixth power, it's still going to be a number greater than or equal to 0. It's not going to become negative. So we definitely don't need absolute value bars there. This one, we don't need them, again, by the same logic as the sixth root of x. We know that x is a positive number. Since if x were a negative number, then the cube root would be negative. But we can't have the square root of a negative since we're only dealing with a real number expression. Therefore, x must be positive, and therefore we don't need absolute value when simplifying. Same logic here. We can reason that x must be positive because if x were not positive, then if x were negative, then when you raise a negative to the fifth power, you're stuck with a negative, but you can't have the square root of a negative since that wouldn't be a real number. So therefore, we know x is positive, or it could be 0. When I say positive, I mean greater than or equal to 0 in this case is what I meant. But x can't be negative, and so we don't need any absolute value bars when simplifying because we know we have a positive. So that's just some tips, and you can ask me about that as needed. Graphing and solving. So for practicing graphing, my advice is know the parent functions and be able to find x and y intercepts. There's a bunch of practice on the TPS. You can go to those, go to the textbook, check my answer keys online, make sure you can do it. State the domain and range. Every time you graph something from here on out in this year, you should be thinking, what's the domain? What's the range? Can I figure it out? And then lastly, solving. To solve radical equations, you're going to isolate the radical expression and raise both sides to a power. Sometimes you'll have to do it twice, and every time you'll have to check for extraneous solutions. Know why extraneous solutions arise. We talked about this in class, and it relates to the fundamental theorem of algebra. Extraneous solutions arise in radical solving because when we solve, we raise both sides to a power. But messing with the degree or changing the degree by raising both sides to a power changes the number of solutions, because we know by the fundamental theorem of algebra, the number of solutions to a polynomial is equal to its degree. So when we raise to a power, we create an equation that contains a polynomial of a different degree, and so we might actually create solutions that aren't solutions to the original. So since they arise through raising both sides to a power, we have to check and make sure that the solutions are indeed genuine or determine that they are extraneous, and then we can reject them. So that's basically a sum up of some things you need to know. Hopefully it gave you some tips. You may want to go back and watch that formatting section again. And now we're going to turn it over to questions and answers. And I'm going to see what I can help you out with as far as specifics. Best thing you could do, make sure you study tonight, put an hour in, put 45 minutes in, depending who you are. You might need more than that, you might need less than that, but make sure you can accomplish all of those skills. Thanks for watching. All right. Let's go to your questions. And I can see some people are formulating questions and still typing them. That's great. I'm going to be answering those in black in a moment and talking about them as well. Let me also just get my sketch pad up so you can see that. All right. Hello, folks. You didn't see me yet. Here I am. I got my new microphone on. Don't know how well it's working, but we'll see. And I'm actually going to share my screen with you and then quickly duck out because it goes to this weird like infinite screen thing. Yep. Okay. So now I am sharing my screen with you. So hopefully you can see the Google Doc with questions, and let's pull up this Sketchpad. All right, here's where I can paste your questions as needed, and I'll answer your questions over here. Will one of the questions on the quiz be similar to the back of the study guide? Maybe not the exact format, but there will be matching questions. So for example, I'm going to give you 5 graphs. I can tell you that much. There'll be 5 graphs and 5 descriptions. Actually, I think it's 5 graphs and 6 descriptions. You're going to have to match the description to the graph. So in a way, no, it's not exactly the same because it's not just like, okay, pick out the equation in state, domain, and range. The description doesn't have to be an equation. The description could be an equation. It might be something about domain or range. It could be something about intercepts or just general curve shape. It might say, or this one is a square root function, or this one is a parabola, and you have to be able to match it up based on that. Okay, so any of those could be the case with the format there. All right, here's another question. I'm going to be answering these questions in black. You can type them in any color you like. How do you know the direction of the curve of the graph of a radical function after you find the vertex? Okay, good question. Notice I didn't say graph any radical function. That was not part of this chapter. You're responsible for graphing square roots and cube roots only. Okay? So if you're graphing square roots and cube roots, you want to memorize the parent functions. The way we derived parent functions by using X and Y charts, which is how you can derive the graph of anything, just plotting a bunch of points. So memorize the parent functions. And that's y equals x to the 1/2, meaning x, the square root of x, as well as y equals x to the 1/3, meaning y equals the cube root of x. Memorize the way those go, and then you'll be able to know the direction. For the negative aspect of it, if it reverses, you should know that those are different, whether it's a square root or cube root, and I can graph an example for you if you'd like. If you want to ask a more specific question about that, what you want me to graph one of them, I can do that. But basically, you memorize the parent functions, and then if it's negative, you alter it. If the center changes, you alter it, and good old stuff like that. There's not going to be like graph x to the 1/4 or x to the 1/5, since we haven't done that, though the parent functions are fairly similar. Okay, my goodness. Someone has snuck in several questions into one question. Wonder who this could be. But I may not answer all these at once, but I can go back to some of them. Can you go over TPS 6.1, number 6, TPS 6.6, numbers 3, 4, and 2? Interesting order here. Perhaps someone added an addendum there. 2, 3, and 4. Yes, okay. Actually, those are not as many as I thought, because I think that's, well, this is a lot. But we'll see if maybe I'll go to the 4th question and then go back to parts of these. TPS number 6.1, number 6, absolutely. Let's pull up 6.1, number 6. And if anything like bugs out with the internet or you don't see what you're supposed to be seeing, just type it up in the "Can you hear me" section or somewhere, and I'll know something's up. But we're looking for TPS 6.1. Thought I had that ready. Sorry for the delay. I don't have it downloaded, so let me download that real quick. TPS 6.1. Here it is. And we want number 6. Okay, let's take that baby and paste her. Copy and paste. I want to zoom in. Let's go to 200%. so that's a screenshot on the Mac. Those of you who have not seen that. Very effective. And here it is. All right, so here's our problem. We want to simplify this guy. Sixth root. So with a number, I mean, you kind of break it down into the sections here. We have the number, 192. We have the x. We have the y to the 5th. We have z to the 8th, m to the 31. If the exponent is less than the index, you don't need to break that down any further. So like this case, the x and the y are to the 5th. Those cannot be broken down. So that's going to be a piece of our final answer. Sixth root of x, y to the 5th. Okay, if those exponents are less than the index, you don't need to break them down further. The z to the 8th we will break down. The m to the 30th we will break down. To break down those variables, you want to break it off into multiples of the index. So in other words, z to the 6th, I want to create a separate piece there, and then z squared, another separate piece. Some of you might be reading a separate piece. Gene and Finney, they don't have anything to do with this problem, but I'll just throw that in there. But this is to the 8th, so I split it into z to the 6th, z squared, because that would create z to the 8th. But notice you want the index to match the exponent there. For this piece, m to the 31, we're going to split that into m to the 30th, not 60th. Sorry about that. Oh, dog. I'm still learning these. Where's the darn eraser? Are you kidding me? How's the eraser not right there? Apologize. Maybe I can use this to select. What did I do? This. Yeah, delete. Oh, gosh. Okay. That was way too hard than it should have been. I apologize. This is m to the 30th. Since we want to create the multiple of 6, since that's going to be able to cancel out. And then we have 1m left over to make m to the 31. And the number 192, I kind of saved that for last. You're looking for perfect sixths that go into that. Perfect sixths are like 2 to the 6th, 3 to the 6th. If it says a power as high as 6, I'm not really going to go to 4 to the 6th because that takes too long to evaluate on the side. So it'll be 2 or 3 if it's to the 6th. And in this case, 2 to the 6th is 64, and 64 goes into 192 3 times. So I'll break it up into 6th root of 64. That's my perfect sixth. And 6th root of 3, since 3 times 64 is 192. Now, by the way, the property that allows me to break all of these up into different little products is property 1. So I'm using property 1 this entire time. All right, now let's simplify. The 6th root of 64 is simply 2. This guy here, the 6th root of z to the 6th, is simply absolute value of z. That's according to property number 4 or 5, 4 or 5. And the 6th root of z to the 2nd, this can't be broken down further. These can't be broken down further. This can't be broken down further. So those are going to be in a big old radicand, as well as the 6th root of m. So we have 3 x y to the 5th. These are all the underlines that can't be broken down further. Z squared and m. Okay. And then now we've dealt with this, we've dealt with this, we've dealt with this, we've dealt with this. I just kind of cross them out that we've dealt with them. We have to deal with this. Now, it's when you treat this as a fraction, it's really m to the 30 over 6th, which equals m to the 5th. The reason I took a little extra second to write that one is because you do need absolute value bars around this m to the 5th. The reason is because m cannot be determined to be positive or negative, because m to the 30th will always create a positive result. Okay, m to the 30th, think, if you do it to the 30th to an even power, it's positive. Then when you take the 6th root of a positive, you'll always get a positive. Okay, so the 6th root of a positive, you'll always get a positive. So this will always come out to a positive if we follow the order of operations. But we really don't know if m is truly negative or not. If m is truly negative, then, well, the result m to the fifth would be negative. So this can't be equal to m to the fifth directly, because m to the fifth could be a negative. This could be a negative, whereas this will always be, the left-hand side will always be positive. So since this will always be positive, when we simplify, we just simply put this in absolute value bars to show that it now will also be positive, because otherwise it could be negative. All right, so that's a basic explanation. There's also another way to think about it where you break it down into 5 different m to the sixths, and each of those requires an absolute value, but that takes a little bit longer. So our final answer, let's clean it up. This would be 2 absolute value bars, z, m to the fifth. And then the sixth root of 3x y squared, or sorry, y to the fifth, z squared m. So that's TPS 6.1, number 6. So I'll say C, video presentation, answer to that. I'm going to highlight these just out of fairness and cut them down to question 6. Can you explain? All right. I want to ask for TPS 6.1 number 4, so I should have that open and ready. TPS 6.1 number 4. There's my zoomer. Oh yeah, this is a quick one. Fun one, but a quick one. And that's one of those ones that looks scary. When you see it worked out, it's not as scary. I want to nuke this whole thing. The full fierce and fury. Okay, force and fury. Anyway, let's find the answer to this when you're simplifying this. Did I get all the radicals there? Is there another radical? Yeah, there's 3 of them. All right, so here the key is you got to remember how to rewrite these as a rational exponent. And the third root of something, the cube root, is simply the same as the 1/3 power. So this expression, cube root of 81, can be rewritten as 81 to the 1/3 power. But then that can become the radicand of this expression, this cube root expression. But this cube root can also be written to the 1/3 power. But then that expression becomes the radicand of this larger radical. So that can be also written to the 1/3 power. And then by the law of exponents that says when you have power to a power, you multiply the exponents. This becomes 81 to the 1/27th. If you want to write it as a radical, if I say simplest radical form, it would be the 27th root of 81. And that's as far as you can go. That was a quick one, and I'll say C, video presentation. Okay, can I explain the top part? I'm going to simplify the top part of the equation, TPS number 6.1, number 3. Yes. Okay, 6.1, number 3. Good one. Good one to pick. A few different skills here. Okay. Nuke this. Okay, how do we deal with this guy? Well, top part, you should be suspicious when you see a 2, an 8, and a 32. Well, I guess you know that this is just equal to 2, since the fifth root of 32 is 2. But when you see an 8 and a 2 and a 32, you might want to just have your eyebrows raised a little bit. Raise up those eyebrows, because these are all powers of 2. And that's a clue that by rewriting them as powers of 2, you might be able to simplify them easier. That's exactly what I'm going to do. Square root of 2 is 2 to the 1/2. Fourth root of 8 is the same as the fourth root of 2 cubed. I'm just dealing with the numerator because that's what the person asked for here. But then the fourth root of 2 cubed is the same as 2 to the 3/4. Rewrite that as a fraction. These are the same base now. 2 and 2 are the same base. The law of exponents says we add the exponents, and that will give us 2 to the 5/4 in the numerator. Okay, you would just carry your same denominator throughout. Subtract these exponents to get a final answer of 2 to the 1/4, or as a radical, it would be fourth root of 2. See video presentation. We're rolling along here. We're rolling, folks. If other questions that arise during any of these, you can let me know. The biggest thing is you have to practice on your own so you know what you don't understand. And clear that up before tomorrow, because tomorrow in class, we are going right full speed ahead into this quiz. Let's check this out. Now we're on to TPS 6.6, numbers 2, 3, and 4. See video presentation. I might ask for some clarification here, because if you need me to go over the entire thing, I don't mind doing that, especially if there's no other questions, but that can take a while. So I might start to give the gist of the explanation and then see if that's enough. So whoever asked that, just stay on board here so I can get clarification from you. 2, we want 3, it's a lot, and 4. 4 we did a lot. We did this in class, so that one I might actually start in reverse because that's a quick one. Let's look at the quickest one first. That's what we're here for. Go over questions. Let's look at the quickest one here. Okay. If you can write the radicand as a power when simplifying, you want to do that because it's going to allow you to write to get through these problems quicker. So, for example, you could multiply by the cube root of 144 squared over the cube root of 144 squared. That will take you forever to break down. You could also break down the cube root of 144 first and then start simplifying a cube root. That will also take you much longer than this method. So I will show you the quickest method. Quickest method is to rewrite 144 as 12 squared. Then you simply multiply by the cube root of 12 over the cube root of 12. The reason being is because 12 to the first times 12 to the second will give us 12 cubed. And by matching the index and the exponent, the result simply becomes the base here. So 12 squared times 12 to the first is 12 cubed. And then when we take the cube root of that, we simply get 12 in the denominator. In the numerator, we have 3 times the cube root of 12. And we just have to ask if that can be broken down any further. And it doesn't look like it. So nothing, no perfect cubes going into 12. We can just simplify this fraction a little bit more. Make that a 4, make that a 1, divide out a 3 there, and we have the cube root of 12 over 4. All right, so I think that was the quickest one of the 3 that you asked about for number 6. So now let's go to number 2. This guy. All right, so isolating the fractional exponent is what you want to do here. When you have a radical equation or an equation with a fraction exponent, you want to isolate that part of the equation. So I want to get this part by itself. So let's subtract 22, and we have 3x to the 5th. Sorry, 3x plus 5. Forgive the handwriting. I'm writing it going a little fast here. To the 7/3 equals 138. Next, we want to raise both sides. This is 7. Raise both sides to a power such that the fractional exponent goes away. We want it to neutralize it, if you will, or simplify it so it's just a 1. So when we do a power of a power, or power to a power, we multiply exponents. So I'm going to pick a number you multiply by. That will just change the exponent to 1, because an exponent of 1 really simplifies the expression. So I'll choose the reciprocal 3 over 7. But whatever I do on the left-hand side, I must also do on the right-hand side. Raising both sides to the 3/7, I get 3x plus 5. And then over here, we have to break down 138 to the 3/7. Okay. Sounds like I did my math wrong here. Any board points? No board points on video presentations. But does anybody see the issue here? If anybody's in tune? You know what? Let's offer a board point. If anybody catches my mistake in the next 20 seconds, I will give you a board point. Just identify yourself by typing under the question 6 area. Board point, if you can find the mistake on the screen in 20 seconds or less. So I'll give an opportunity to see who's really paying close attention and who is not. And that is Gwyneth Gaynor coming through with the board point. Yes, Gwyn, it is 122. I'm sorry, 128. Thank you for that correction. So Gwyn is correct. This should be 128. Sorry, when you subtract 22, it's 128. So we end up with the, I'm going to translate this now into a radical. This is going to be the 7th root of 128 to the 3rd. Turns out that 2 to the 7th equals 128 exactly. All right, so this is a perfect 7th, if you will. And this expression is just 2. And then we raise it to the 3rd power. So just 2 to the 3rd. 3x plus 5 equals 2 to the 3rd. That's 3x equals, this is 8 minus 5 is 3. And so then we have x equals 1. Double check if it's extraneous. We have 3. Let me just double check this here. Okay, did I do this right? X plus 1. Okay, yeah. So in our parentheses here, we have 3 plus 5, which is 8. I'll take the cube root of 8, which is 2, raise it to the 7th, which is 128, add 22, 150. Yeah, checks out. It's a real solution. Good to go. Okay, so I'm going to say see video presentation. I'll now start number 3, but I'm going to ask whoever asked this question if you could, let me know any specifics you have about this, and then I will try to address those. But I'll get you started here just with the method, and you can let me know what issues you had. But the method is to treat this as a system of equations. Well, it is a system of equations, but I mean almost treat it as a system of linear equations. So back when you were in Algebra 1, you solved stuff like this: 2x minus 3y equals 10, and 5x plus 1y equals 42. And you did stuff like that. You would try to get these coefficients to be opposites, okay? Either in front of the y's or in front of the x's, you want those to be opposites, and then you can eliminate a variable by combining the 2 equations. We would do the exact same thing here. So I'd multiply, for example, the top equation by 3 and the bottom equation by 2, and that will allow the coefficients of y to become opposites. When they become opposites, they will add to 0 when we add the 2 equations together. So this is 15 root x minus 6 root y equals 3 times 4 root 2 is 12 root 2. The second equation times 2 is 4 root x plus 6 root y. Yeah, those are the ones we wanted to match. And then 26 root 2. Add these equations together. These add to 0. We have 19 square root of x. This actually can get tricky if you don't have a calculator. You got to be careful here. And then these add together. These are like radicals. So we add those coefficients, quote unquote, and we get 38 root 2. If you try to square both sides now, you're going to have to square 38 and square 19. It's going to be a pain in the neck. So my advice is divide by 19 first. Let's really isolate that radical expression before squaring both sides. That gives us radical x equal to 2 root 2. Now square both sides. And that will give you x equal to, this is 2 squared is 4, root 2 squared is 2, 4 times 2 is 8. Plug it back in, do the math, and you'll get y equals 18. If you have another specific question about this, I could go through a different part, but that's the general answer to the video presentation. Okay, now it's only 4:40. So I'm willing to stay on until 5 o'clock, or even more. I said 5:15, if people have specific questions. But if not, I will close the video presentation. We'll close this webinar and allow you to get back to studying and other things like that. But I'll give you folks a couple of minutes just to see if you have any last-minute questions about any different aspects of the presentation, of the review, questions on the TPSs, or anything like that. We'll just take a few more minutes, give you a chance for any last-second questions. And if not, we will close out this webinar and go from there. Oops, I can't open that window. I forgot. Also, I did remember this. I know this one's going to be a little light. We only have about 6 or 7 people watching. I see 4 of you here now, but the reason is on Monday, a lot of people have different schedules, different things going on, and may not be able to make it. So they might be watching the replay and not get their questions in. But anyway, I'll stay on for a couple more minutes to see if you have any questions, and then we'll go from there. Any more questions? Once. Twice. Okay, we're going to close this out. I'm going to say sold. Thank you, those of you who joined. And next time, hopefully we'll have a little bit of a bigger turnout. Hope the new microphone worked well, and I hope you study for this quiz tonight and do really well tomorrow. So thanks for joining us for this webinar, and I will see you soon. Have a good Monday.